Yeah, no. Okay, so integration day 5, additional formulas that may be useful, blah, 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 blah. Subtle integrals involving arc trig, inverse trig functions. Do. Okay, we're kind of flipping to the middle of page 2. Any equation involving a derivative is called a differential equation. Differential equations arise in chemistry, physics, mathematics, and all branches of engineering. We'll only scratch the surface of this. Yeah, I've done up to 300 level third-year courses of differential equations. They go even farther than that. Yeah. You can model just about anything with a differential equation. Yeah. Airflow, magnets, stresses on beams. Yeah. Consider the differential equation dy over dx equals x. What does this mean? Could you state this equation another way? How do you solve it? So what this is saying is on a piece of graph paper, the slope at every single point on the curve, it just depends on the curve's, just depends on the x coordinate. Okay, so the x coordinate of this point is 1, so its slope is 1. The x coordinate of this point is 2, its slope is 2. The x coordinate of this point is 3, its slope is 3. So what does this mean? It means that the slope everywhere depends only on its x coordinate. Can we state this equation another way? Well, we could state it this way. How do you solve it? You take the antiderivative of both sides. So instead of taking the derivative of both sides, we take the antiderivative of both sides. The antiderivative of 1 dy is just y. The antiderivative of x dx is 1/2 x squared plus c. Now this is a very special branch of differential equations. There's all sorts of different kinds. These are just called separable differential equations because you can separate the x from the y's. Okay, but there are going to be ones where you can't separate. And they're different kinds of first order linear, second order linear, different. Yeah, you don't care. Okay, so solve the following differential equations. Okay, let's do that. So dy equals x cubed dx. Take the antiderivative of both sides. The antiderivative of the left-hand side is 1. The antiderivative of the right-hand side is 1/4 x to the 4 plus c. Well, that's close to 730. Not bad. dy over dx equals, okay, number 2. Antiderivative of dy is y. The antiderivative of x to the 4th plus 2x minus 2x squared plus 1 is 1/5 x to the 5 minus 2/3 x cubed plus x plus c. Yeah? X sine, ooh. So, Mr. Up, we're going to let u equal x squared. Du equals 2x dx. Don't see a 2. Put it over here. I think I'm painting myself into a corner. I'm running out of room. Antiderivative sine is cos. Negative cos, is it not? Yeah. Yeah? Yeah. Yeah. It's always got to be y equals when you're done. Okay, what about this one up here? Y dy equals x dx. Now what blows your mind away is those are two different constants that have two different values, so when they combine together they don't create 0. So you could, if you want to number them, C1 and C2, but I just call them all C, it doesn't really matter. No, will not. So you take C1 over to the other side and you go C2 minus C1 and we'll call that C3. You can see, and then you get rid of the 2 off the y squared, or the half off the y squared, you're left with y squared equals, multiply everything by 2, and you get x squared plus c4. Well, you could write it as 2 times c3, but we don't. And then you square root, and you get y equals plus or minus the root of x squared plus c4. That far. It's not that bad. Okay, so you're looking. Oh no, we're integrating implicitly. So you get dy over y equals x dx. The antiderivative of the left-hand side is ln take the C1 and the C2 and combine them together and create C3. Haha, PO. Get rid of the ln. Yet. Yeah, eat all that. So it becomes y equals e to the 1/2 x squared plus c3. Now I'm going to blow your brain away a little bit. No, I'm not. It's okay. You can also write it like this. Yeah? It's not, is it? That's why we just call it C4 down here. Because, yeah, we don't, we just call it a constant out in front. We actually call it the letter A, but, or P0. Hey, remember poke it? It's P0, but anyway. Okay, is there one up here to do? Oh, look at that, number 6. So get dy over dx, okay, so dy over the root of y equals x squared dx. So you can write it as the integral of y to the negative 1/2 power dy equals the integral of x squared dx. Okay, add 1 to y. You get positive 1/2. Divide by positive 1/2 plus c equals 1/3 x cubed plus c. Make it y equals. So you get 2 root y plus c equals 1/3 x cubed plus c. Now what? So combine the c's together. Hey, look, c1 plus c2 equals c3. Actually, c1 minus c2 equals c3, but who cares? They're just all constants. So you have 2 root y equals 1/3 x cubed plus c. Divide both sides by 2. Root y equals 1/3, 1/6 x cubed plus c. The constant's just changing as we need it to. No, because what? No, because when we do 3 over, when we do 3 comma 9, all we're going to do is put 3 in for x, 9 in for y, and make the c work. Square both sides. 1/6 x cubed plus c all squared. So what we're going to do is we're going to put 3 in for x, 9 in for y, and figure out our c now. No. Yeah? Whatever that is. 27 over 6. 9 over 2. Okay. The meaning of c. Go back to the differential equation. dy over dx equals 2x. Okay. What does c mean graphically? Well, all it means is the slope. Okay, so what this is saying is everywhere on the curve, I'm just going to draw some, whoa, way too many dots. Holy, that's bright. Okay. So you just draw a 9 by 9, an 18 by 18 grid. I think it's late tonight.
Okay.
Yeah.
And there's a practice?
Nope.
Okay.
We're all done. Smile. We're all done.
That's good.
Yeah.
It's so late dinner.
Yeah.
Okay.
Yeah. Yeah. So as we go from left to right, all I'm going to ask you what the x value is, and I'm going to draw a little blue line that represents the slope there. So the slope, the point right here is -3. Its slope is -6. -4, -2, 0. +2, +4, +6. And that pattern continues for all of these points. Would you agree? I wish I could draw. Yeah, stop. Yes. What this C means is it's talking about a particular path through the maze. So if I said you had to go through this point right here, the path through the maze would be like something like this. It's just it's the constant that says pick this path through the maze. Join these little bits of lines together. Okay? That's what it means. Kind of get it. Instead of saying, because do you see that each of those groups of blue lines, they create families of parabolas, groups of parabolas, and then when I say this is the C I want, instead of saying all of these parabolas work, only one of them will work. Yeah? Yeah, okay. Suppose the tangent line to the... I got to read the question. Suppose the slope of the tangent line to each point, curve y equals f of x is x, and the curve passes 2, 3, find the specific... The slope of the tangent line to the point of the curve is... Okay, so what it's saying, you got to read this, it's hidden in here, but it's saying dy over dx equals x. Okay, find me the solve, find y, make y equals. What do you got? You get dy over dy equals x dx. So take the antiderivative. Y equals 1/2 x squared plus c. It says find the specific curve. It says it passes through the point 2, 3. What are you going to do? That's it. So the curve is so we've gone from a whole family of curves which is what this is, down to a specific one. Ooh, if f prime of x equals 3x squared and f prime of 1 equals 3, fine. Same thing. Take the antiderivative. Take the antiderivative. The antiderivative of f prime of x is just f of x. The antiderivative of 3x squared is? X cubed plus c. Substitute 1 in for x, 3 in for y. You find out that c is 2. Given the almost done. Yay! So you get y equals ln absolute value of x plus c. It says y is -3, x is e. Pardon me? Are these hard? Can they? Oh yeah. Okay, so velocity of blah 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 blah. If the particle is initially at x equals 3 on the line, find its position when so what this is saying is s of 0 equals 3. And it wants you to find s of 2. So we go backwards. We take the antiderivative of velocity. Yeah, what? It says if initially the particle is at x equals 3 on the line. So what it's saying is this. It starts right here.
Ms. Chamberlain, can you please call the upper campus office? Ms. Chamberlain, please call
That's
the
what
upper
it should have
campus
said.
office. Thank you.
Should have said initially the particle is at s equals 3 on the line. No. No, we only move along. Well, sure, I don't care. We can move it on the y-axis if you want. No, but okay, you guys are getting particles moving back and forth along the line, and coordinates mixed up. This is just a, you know, it's just this dot moving back and forth. Sorry. Yeah. It doesn't matter. I mean, I could have started here and done the same question. So take the antiderivative, you get position. Take the antiderivative, you get t to the 4th minus t cubed plus c. So when t is 0, or y value is 3, or x value is 3, or s value is 3, so you get c equals 3. So your s formula becomes t to the 4th minus t cubed plus c s of 2. Oops, we know what c is, silly. 16 minus 8 plus 3. 11. Okay, two more. An automobile ends from standing start with a constant acceleration of 0.6 meters per second. So what we're saying here is s double prime of t equals 0.6. How do you find s prime? Yeah. 0.6 t plus c. Now, accelerates from a standing start. So we know that its velocity is at time t equals 0, it's 0. And we know its position at time t equals 0, it's 0 as well. Oops. So how do we go backwards to s? Take the okay, so we should probably do this first. And you find out that c equals 0. I was just speeding along too fast. Yes, you do. An automobile accelerates from a standing start with a constant acceleration. Your standing start, you have no velocity. So it's like you sitting at a red stoplight and you hammer the gas pedal. Right? You have no velocity until you release the brake. Take the antiderivative of that, you get s equals 0.6 t squared over 2 plus c, and you get s equals 0.3 t squared plus c, and when you put 0 for t in and 0 in for s, guess what you find out c is? 0. Physics people, you ever seen the formula? Distance equals 1/2 at squared. Guess where it comes from? This. That's your answer. And then how much does it travel in the first 10 seconds? Put 10 in for t, and you know how far it travels. 100 times 0.3 is 30 meters. 30 meters? I don't know, do we want to do the next one? 5. Suppose the acceleration of the particle is given by the v01 is f2 is 5. Let's just do it. So what's the antiderivative of 4t minus 3? What? 2t squared minus 3t plus c. Now what are you going to do? Put 1 and 6 in. 6 equals 2 times 1 squared minus 3 times 1 plus c. 6 equals negative 1 plus c. C equals 7. So your new formula is v of t, nice, v of t equals 2t squared minus 3t plus 7. And how do you find f of t? You take the antiderivative. 2/3 t cubed minus 3/2 t squared plus 7t plus c. Put in 2 for t, 5 in for f of t, and solve. Dun dun dun. Now I will warn you, because I made my worksheet up before I made these examples, my worksheet is evil compared to these. Absolutely nasty. I am quite proud of myself. That's not a good thing, Mr. App. Yeah, I know. So, when you are looking at the 6.2 supplement at the very bottom, when it has the differential equations at the bottom, do not be surprised if you get frustrated with some of them, because, oops. Maybe you want to start at the end and work your way back, because then you might feel good about yourself, because the ending questions are more like these. Okay? Yeah? I posted all of them on the web for answers, so you could check as well. But anyway. I have a